different angle relationships today. Like I said a while ago, some of you know some of the stuff, some of you might not be as familiar with it. The first thing we want to talk about is what adjacent angles is. Adjacent angles are two angles that lie in the same plane, have a common vertex and a common side, but no common exterior point. When you have two angles that are adjacent, it's like they're neighbors. Miss Turner and I have adjacent classrooms. Adjacent means next to, okay? We share this wall right here. That's the only thing that we share. Her classroom doesn't spill over into mine doesn't spill over into hers, okay? We're just right next to each other and we share a wall. Well, adjacent angles are right next door to each other, and they share a vertex and a red. That's it. So if you look at these two examples right here, these are examples of adjacent angles. So if you look right here, this angle 1 and angle 2 share a vertex and a red, and that's it. Okay, so they're considered adjacent. Likewise, these two share a vertex and a red. Okay, they're right next door to each other. If you look at these two examples, these are not adjacent. Okay, for reasons. If I just look at this picture of an angle ABC at 3, it appears they're adjacent. And honestly, this angle and this angle are adjacent, right? But if I were to talk about this angle 3, okay, which is everything in there, and this angle ABC, which is everything here, what's the problem? They overlap, right? Okay, so the blue and the purple overlap each other, and so these are not considered adjacent. Okay. And if you look at this angle ABC, which is this angle right here, and this angle 3, which is this angle right there, they don't even touch at all. Okay, so they're not neighbors at all. And then purple, they might be in the same neighborhood, but they're not next door neighbors, right? They're across the street from each other. All right, so that is what adjacent. Now, a special type of adjacent angle are linear pairs. Okay? It's a pair of adjacent angles whose non-common sides are opposite rays. And it uses the word linear for a reason. Because if you look at this example right here, see angle 1 and angle 2, they're adjacent. Okay? They share a vertex and a ray. Okay? And it says their non-common sides are opposite rays. Do you remember what opposite rays do? What do they create? They create a straight line, right? Okay? So this one right here goes this way, and this one right here goes this way. Okay? So that's considered a linear pair. I have two people with Chromebooks up. Come down, please. Alright. Their non-common side forms a straight line. Hence, linear pair. Okay? Sometimes it's helpful, like if you're uncertain if they are a linear pair, take a piece of paper. If you put it up to them, if the two angles form a straight line, you know that they're a linear pair. Okay? Alright, these are not a linear pair. If we look at angle ADB, and we look at angle ADC, those are adjacent, yes? They're neighbors, right? But look at their non-common side. Okay? Going in wonky directions, they don't form a straight line. If I take the paper, okay, you know, it doesn't make a straight line. Okay? Alright, so that is what linear pairs are. Now, linear pairs have a special relationship we're going to talk about in just a second. Another pair of special type of angles are vertical angles. And those are two non-adjacent, because they're not neighbors, okay? Two non-adjacent angles formed by two intersecting lines. Okay? So, when you have vertical angles, you have two lines that intersect. Here, and you have a line here. Okay? Those two lines intersect each other. And when they do, four angles are created. Okay? And the ones that create these with each other are considered vertical. So if we look at angle 1 and angle 2, those are that's a vertical angle pair. Okay? If I look at angle 3 and angle 4, those are vertical angle pair. Oh, I had it written down right there. Those are vertical angle pair. Okay? Alright. Here's some examples that aren't. Here I have a line It's two angles, okay? And they're not opposite. So these, I don't have any vertical angles here. Even though there's four angles, they're not created by two intersecting lines, okay? So those are just regular angles, right? I do have a linear pair with 6 and 7. You see that? See how they form a straight line? And actually 5 and 8 do as well. But I don't have the vertical angles here, okay? Over here, I have vertical angles in 1 and 2, and then I also have linear pairs with 1 and 4. You see that? Okay, with 1 and 3. With 2 and 4, and 2 and 3, okay? So I get vertical angles that make them easy with each other, okay? And then also this one here. Alright. Name two obtuse vertical angles. What does it mean to be obtuse?
More than 90 degrees.
More than 90, less than 180, right? Okay. So, do I have a pair of obtuse vertical angles? Okay. If I look here, I've got these two lines that intersect each other. Okay? So what would my obtuse vertical angles be? Y, C, B, the B is X, right? Angle B, Z, X, and what else?
Y, Z, W.
Y, Z, W. Do I have any acute vertical angles?
Yes.
What?
Y,
B, C, Y, and
Y, Z, C, W.
Y, Z, W. Right? No, Y, Z, W. B, Z, wait. B, C, Y, and X, Z, W. Some reason others all get mixed around when I try to name it. So the two that I have marked in red, okay? B, Z, Y, and X, Z, W. Okay, those would be my acute vertical angles. And then my obtuse are B, Z, X, and Y, Z, W. Okay? Alright, name a pair of adjacent angles. Name a pair of adjacent angles. There's lots of different ones that I can choose. And let me start with one. Let me start with angle YZ. And you can name an angle adjacent to that one. So YZT, what would be something adjacent to that?
TCW.
TZW. Or I could have said what?
YCP.
YZB. Okay, so if I chose this angle right here, then I could use this one or that one, right? Okay, so there's lots of different things. Alright, now, some special things about vertical angles and linear pairs. Vertical angles are always congruent. Okay? Vertical angles are always congruent. So what would be my vertical angles here? 1 and 2. And so angle 1 is going to be congruent to angle 2. Okay, and I can mark that. Angle 1 and angle 2. Remember those little arcs? Single arcs indicate that those two angles are congruent. Do I have another pair? Okay, angle 3 is congruent to angle 4. And so I would not use single arcs because they're not equal 1 and 2, but I would want to use double, right? Okay, because they're okay. The sum of the measures of a linear pair is equal to 180 degrees. So anytime I have a linear pair, they're always equal to 180. If I take this right here and put it, I can move this up right here. And do you see that this angle right here, that one's like 45 degrees? This one right here is like 135, right? That together, they equal 180. This straight line measures 180 in degrees, okay? So that's what happens. Anytime you have a linear pair, they're going to add together to get to 180. Alright, so let's write that down. The measure of angle 5 plus the measure of angle 6 is 180. What are two angles that add together to equal 180 called, other than a linear, in this case, a linear pair? Anybody know? What kind of angles add together to equal 180? Yes. Supplementary angles, which takes us to our next page. Actually, it talks about supplementary. The supplementary is down here. Okay? Let's skip complementary. Come back to it. Supplementary angles are two angles whose measures have a sum of 180. So anytime you have a linear pair, they're always going to be supplementary. Okay? But they don't have to be a linear pair to be supplementary. You can have two random angles, like one that's 60 one that's 120. One could be over here, one could be down here. If they add together to equal 180, they're supplementary. Okay? Alright? Complementary are two angles who has a sum of 90 degrees. Okay? Now, if they are adjacent, what do you mean to be adjacent? Next to each other. If you have a pair of complementary angles that are right next to each other, what do they form? Big picture. They form a right angle. This right angle measures 90 degrees, right? Okay? So, they can be adjacent and together form a right angle. Or again, they can be just two random angles. A 30-degree angle on one side of the page, a 60-degree angle on the other side of the page, and they add together to equal 90. That means they're complementary. Okay? Okay, so complementary adds together to equal 9. Supplementary adds together to equal 180. Okay, find the measure of two complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller angle. Okay, some people really hate this problem, but these aren't really too bad. What do we know about complementary angles? They must equal 90 degrees. So you've got one angle plus another angle, and those are going to equal 90, right? And it says that the larger one is 12 more than twice the measure of the smaller. Do we know what the smaller is? X is the smaller. We don't know it, so we're going to let it be X. Then it says the larger is 12 more than twice the measure of the smaller. What's that? 2x plus 12. Okay, more than means add, and it is 2 times, not twice. So 2x plus 12. Together, they equal 90. Make sure you use the smaller one and the larger one together. Sometimes people just try to use that larger one because I include the smaller one too. So if I want to find out what both of these angles equal, then it would solve. That would give me 3x plus 12 equals 90. And I'm going to subtract 12 from both sides. So I have 3x equals 78. I'm going to divide both sides by 3. And that ends up being 26 degrees. Okay? So, x represents my smaller angle, which is 26 degrees. What am I going to do to find my larger angle?
9 times 2 times 6 plus 12.
Okay, I hear two different things. Some people think take the 26 and plug it in for x, right? Multiply by 2 and add 12. Absolutely, that works. But I also know that the smaller angle and the larger angle are complementary, which means what? They equal 90 degrees, so you can do 90 minus 26. So either way works, okay, whatever you're more comfortable with. So that what gives me 64 degrees, is that right? Okay, so I can either do 90 minus 26, or I can do 2 times 26 plus 12. Okay, either one of those are going to give you the right answer. Okay, all right. Perpendicular lines. We've talked about this already. Perpendicular lines are lines that form 4 right angles. This is the symbol that we use for perpendiculars, like an upside down T. Okay? If I'm going to tell you that 2 lines are perpendicular, it looks something like this. Line WY is perpendicular to line SC. So, I can take and I can draw them. If they intersect each other, and if they're perpendicular, then I know that they form a right angle. Actually, they form 4 right angles, right? Because remember, vertical angles are congruent, and linear pairs equal 180, right? Okay, so if you get one right angle pair, you've got 4. All right. And so, if, let's say I come into a problem like this, I can assume that this is right, this is the box. Okay? Or, if I have this statement right here, and I have the picture drawn, then I know I can add the box. Alright. Find x and y so that BE and AD are perpendicular. Okay, so if BE and AD are perpendicular, what do they form? They form right angles, right? 4 right angles, yes? Okay, so if I want to find x and y so that they ensure that they are perpendicular, what would I do to find x? Well,
6 plus 5 equals 90.
okay, so add them together and set them equal to 90, right? Okay, that makes it perpendicular. So I end up with 9x minus 9 equals 90. Add 9 to both sides. and x equals 11. Okay, so that takes care of 1. All right. What about y? What am I going to do with it? Just set it equal to 90. Okay, there's got to be a right angle there. So 12y minus 10 equals 90. Add 10 to both sides, makes it 100, and then divide both sides by 12. Don't get the nicest of numbers. 100 divided by 12 is 8.3 e. Or 25 thirds. There's a school button. If you have this kind of calculator right here, there's a button right above the equal, the enter, it's like arrows going both ways. That'll toggle that between decimals and fractions. And we'll also talk about graph and their testing. Okay, so you don't have to mess with the modes so much. Okay. Alright. Last one. Determine whether each statement can be assumed from the figure below. Angle LPM and angle MPO are adjacent angles. So LPM and MPO are adjacent angles. Yes, that's true, right? They share a vertex and a ray, correct? That's it. Okay, so I can say they only share a vertex and a ray. Okay, the next one. All right. Okay, OPQ and LPM are complementary. Some say yes, some say no. What do we know about those two angles? They're congruent, right? But do we know what their measures are? They could both be 30, couldn't they? Would that make it complementary? No, what would they both have to be? They'd have to both be 45, and I don't know what they are, okay? So my answer here would be no. We can say they are congruent, but no indication is given for their measure. Okay. All right, last one. LPO and QPO are a linear pair. LPO and QPO are a linear pair. What do you think? Yeah, they are, right? Why? They're on the same line, right? They're adjacent, okay? So they are neighbors. They are adjacent. And they form a line, yes? They're adjacent and they form a line together. Okay? Alright. So, when I say, so we talked about adjacent, they're neighbors, right? They share a ray and a vertex, but that's it. They don't overlap each other. They're right next to each other. If I say the word linear pair, this picture right here should pop into your mind. And then you should say, okay, well, if they're a linear pair, they add together to equal 180. If they add together to equal 180, that means they are supplementary, yes? Okay, so you should know that. Okay? If I say the word vertical angles, then this picture, or that picture right there, should pop into your head. Okay? And what do we know about vertical angles?
Offset angles.
The vertical, they're congruent to each other. So if angle 1 is 60 and angle 2 is 60. Okay? What else do we have going on here with 1 and 4?
They're congruent.
They're not congruent. 1 and 4 are, they're a linear pair. Remember my paper test? Okay? Remember my paper test? They're a linear pair, which is 180. So if angle 1 is 60, angle 4 is 120, which means angle 3 is also. Okay. All right. about complementary, which means they add up to equal 90, right? They can be adjacent or not, okay? Supplementary, it means they add up to equal 180. They can be a linear pair or not, okay? And then we talk about perpendicular. Remember the symbol for perpendicular? What does it mean to be perpendicular?
They never intersect.
No, that's parallel. It creates 4 right angles, right? It creates 4 right angles. All right? Okay.